In this video, we'll talk about a few things related to using Entity Framework Core. Specifically, we'll talk about a couple of open source alternatives for backend database, and we'll see why using lazy loading may not be such a great idea. And we'll see how to configure things like a connection string. And very importantly, we'll see how to use the Entity Framework Core command line to generate database schema from model classes. First, the alternatives to Microsoft SQL Server. SQL Server is a great database system, very fast, lots of features. But the problem is that it's kind of expensive. You can use it for development for free, but for production use, you'll need to pay lots of money. If you want to do a project for a more cost-conscious client, like a small business or a nonprofit organization, you may want to consider some open source alternatives. Fortunately, with an ORM solution like Entity Framework Core, it's easy to switch to a different database system. As we saw in the last video, the application code uses LINQ to query data instead of a DBMS-specific SQL dialect. So changing to a different database system doesn't affect the application code much. The Entity Framework Core documentation lists the database systems that support EF Core through the so-called database providers. For example, we can use EF Core with SQL Server. We can use it with the embedded database SQLite. We can use EF Core with an in-memory database and other popular open source DBMS like MySQL, Postgres, and so on. One thing I want to mention is that if you use MySQL, which most of you are familiar with, you'll see that there are two database providers here. One from the Pomelo Foundation or Pomelo Foundation. Pomelo Foundation? Okay. And the other one is from Oracle. Oracle owns MySQL, so the Oracle one can be considered kind of the official one. But I would actually recommend the one from the Pomelo Foundation because it had better support for EF Core features in the past. If you look at the download statistics of these two packages, this one is Pomelo Foundation one. It was downloaded more than 12 million times before, and this one's the Oracle one, and it was downloaded 150,000 times before. So there's about 10 times difference, and the Pomelo Foundation one is much more popular. So if you use MySQL, I'd recommend that you use the database provider from Pomelo Foundation. And okay, so now let's talk about lazy loading. We discussed lazy loading in the last video. Basically, it loads data from database only when we need it. And for example, if we load an employee object from database, it will include the supervisor ID, but not all the supervisor object information. And if later in our code, we try to print out the supervisor's name, the ORM tool will automatically generate another query to get the supervisor's information. And again, if we need a supervisor, it will automatically send another query. You look at this and you may be thinking, this seems great. I want to use lazy loading all the time. Well, not so fast. One thing you may not be aware of is that if you know what data you need, it's actually much faster to get it with one query than letting lazy loading to do it with multiple queries. The reason is no matter how simple a query is, there's certain cost associated with it. For example, the query has to be sent to the database and the results have to be sent back, and this round-trip communication cost is actually quite significant. And then there are other per query costs like parsing the query and coming up with a query plan. And also database operations usually involve disk I/O. And the disk I/O is another place where reading lots of data at once is much more efficient than reading small pieces of data multiple times. All this together mean although lazy loading sounds good, it can make your application run much slower than it should be. A common example to illustrate the problem of lazy loading is called the N+1 problem. For example, suppose we want to print out the supervisors of each employee. We can do a employees to list to get all the employees, and then we can use a for loop to iterate through each employee and print out their supervisor. The code looks simple, but it's actually very inefficient because it takes one query to get all the employees, but then lazy loading will send one more query for each employee supervisor. If we have n employees, this code will take n+1 queries, hence the name N+1 problem. A much more efficient way is to use a join query to get all the employees and their supervisors together. The code would be slightly more complex, but the performance will be much better. So, shall we use lazy loading? The short answer is no, because for any non-trivial project, you will almost certainly run into performance problems. Fortunately, EF Core makes not using lazy loading easy by providing several other options. For example, we can do lazy loading only for some classes instead of for all. We can explicitly load some related objects after our object is loaded, or we can load all the data at once using an extension method called include. The eager loading option is what I recommend and what I will use in the examples later in this course. You can check out the documentation for examples of how to use the other options. The next thing I want to talk about is moving configuration out of code. So this is the example we did last time, and as we can see here, in this example, we hard-coded connection string here. There are two obvious problems. First, if we want to use a different database, like switching from a development database to a production one, we'll have to change the code and recompile. And second, if we share code with other members on the development team, they will see our username and password. Both problems are pretty significant. Generally speaking, there are three places we can put configuration information. We can put them in environment variables, we can put them in configuration files, and we can put them in some kind of secret vault like Azure Key Vault and AWS Secrets Manager. The third option is specific to applications that use certain services like AWS or Azure Cloud Service, while the first two options are more universal and available to pretty much all types of applications. .NET Core supports all three options, and you can check out the documentation here for more details. In this course, we'll mainly use a configuration file called appsettings.json. It's the default configuration file for ASP.NET Core web applications. And as we'll see in a moment, It can also be used for .NET Core console applications. As you can probably tell from the file suffix, the file uses JSON format. The whole file is basically a big JSON object, and the configuration information are basically key value pairs as properties of the object. Sometimes you may have several configuration properties that are related to each other, and in that case, you can group them together into an object under one property. And this property is usually called a section. Because connection strings are often stored in configuration files, there's actually a special property called connection strings. You can put all your connection strings in this section and give each connection string a name. Even if you only have one connection string, you should still have a connection strings section here with one connection string inside. This is because, as we'll see in a moment, there's a special command used to get connection strings from the configuration file, and it will look for the section called connection strings. So once we have a JSON configuration file, we can load the configuration information into our application using the configuration.json package. So let's do that. The first thing we'll do is we'll add that package to the dependency of the project, and we'll do manage new get packages, and the name is this. So we'll get this one. Okay. And then we'll need to create the app settings.json file, and let's do that. And we'll do a new item, and let's search for JSON. So let's add a JSON file, and it's going to be called app settings.json. And let's put a few properties in it, and let's say we have something like this. We'll have a key called some property, and okay, it will have a value called some value, and we'll have a section, and inside the section we'll have a couple of property keys and a couple of property values, and in the connection string section, let's put our connection string here. So this is going to be the connection string. We'll put it here. And we'll give this connection string a name. And oftentimes the name is called default. So this is going to be the default connection string. And if you have more connection strings, you can add them here. But we only have one here, and the name is default. Name doesn't really matter. Just like any other configuration property names, you can give it pretty much any name. Okay, so now we have the library, the property file, and then let's put it into the code. So now inside the code, we no longer hard code the connection string here, and we'll load the configuration file, and this one imported. This one will imported this, and okay. So so this code basically loads the configuration file into a variable called config. Then where do we go from here? If we mouse over this config variable, we can see that it's of this type called iConfigurationRoot. So time to hit the API documentation. Okay, so this is the API of this iConfigurationRoot interface. And notice that this interface implements, or in other words, inherits from another interface called iConfiguration. As we can see here, most of the iConfiguration root properties and methods are actually inherited from iConfiguration, and there are some extension methods, and all of them deal with iConfiguration as well. There are a couple of important things here. First, this indexer here allows us to get any configuration property value by providing the property name. For example, we can say config, and then we can say some key, and it will return the value of that property. And if a property is in some section, like in here, we can use a special syntax for the indexer key. So we can say section name, and then column, and then the property name. And this will give us the values of a property inside a section. So that's pretty convenient. The second important thing is the extension method. That that gets a connection string. It's this one. Yeah. As I said earlier, because connection strings are often stored in configuration files, there's actually a extension method just for that. So here, instead of using the indexer, we can use the get connection string extension method to get us connection string using its name. Now, let's see how this thing works. So here, for example, I have a key called some property. So we'll print out the value. We'll say console write line, and we'll say config and some property. That's the property name, I think. Yeah, some property. And then we have a section with two properties. It's called some section and property one. Okay, so let's try this one, and this one will be some section property one, and this should give us hello. And here, instead of the previously hard-coded connection string, we'll say config get connection string, and the name of the connection string is default, so we'll say default. Okay, so this should do it, and let's run this code. So we're getting an exception that says, oh, file not found exception. Okay, I forgot to mention one thing which is actually kind of important. After we created the app settings.json file, click on it, and underneath we can see the properties of the file. And inside this properties, there's a property called copy to output directory. And we want to change it to either copy always or copy newer. What this one means is that this file, when we create it, is under the source code folder. But we want to automatically copy this file to the output folder, meaning the folder that contains the executable files and binary code and so on, so that later on when we run the code will find this file. And to do that, we just need to set the property to either copy always, meaning that this one will always be copied to the output folder, or copy if newer, meaning that if we change this to a newer version, it will be copied again. I'll usually just use copy always just to be sure it's always get copied. And if we run this again, um, if we run this again, I think we will get another exception because because I deleted all the tables in my database so that later on we can see how it looks like by recreating it. So here, notice that we did get some value and hello, but nothing here because I have deleted all my tables. And yeah. So because of that, it will get an exception here that says it couldn't find any employees, and that's okay. We'll come back to this later after we recreate the tables and so on. So actually, let me just comment out on this so that it won't affect things. So we'll create a database and we'll, let's say we just find one. Okay, so again, this code won't work right now because we don't have any table in the database yet, but we'll see it will work later on. Okay, so this is how we can use a configuration file to move configuration information out of the code, things like connection strings and other things that you don't want to hard code in the application. Now, one more thing about configuration files, do not put them in your source version control repository. This is especially important if you use a public Git repository on GitHub. If you put your configuration file there, the whole world will see your username and password. Instead, I recommend that you put your app settings.json file in git ignore and the source control a sample configuration file instead. So something like this. So right now, this project is actually not version control. So let me first rename this one to sample. And then let's add this to version control. And I'm going to do a local only. So now this one is version controlled, and what we'll do is we'll switch to the folder view. And the folder will show us the Git files like git ignore and the Git attributes and so on. So in the Git ignore file, we'll add app settings.json so that we don't accidentally add app settings.json to version control. And then we can go back to solution. And then here, let me go to the project folder. And let me make a copy of app settings.json. And now this is going to be the one that we'll use locally with the real account information and so on. And then this one will put some, placeholders in it. We'll say user ID is CY-Song and password is ABCD, something like that. And this app settings.sample file will get version controlled and shared with other developers on the team. And this one stays on the local machine with the real account information. So this way we don't expose our account information, and other people working on the project can still know what information needs to be configured from the sample configuration file. Okay, the last subject I want to talk about in this video is using EF Core command line tool to generate database schema from model classes. But before we do that, let's take a quick look at the .NET Core command line tool first. .NET Core CLI is a useful set of command line tools to create, build, and run .NET Core applications. You can see the full reference here. This one. And let's do a quick example of using .NET Core CLI to create a new C# console project and then run it. So to do that, we use .NET and then the new command. And the new command says it takes a template, and then we can specify an output folder. And there are some other options. We don't really care for now. So among the templates, the one that we want is this one, console. So the command line tool would look something like this, work something like this. And so let's say we'll say .NET new, and the template is console. We're going to output into a folder called console F1. So now notice that it creates a folder called console F1, and inside console F1 we get the C# project file, and we also get the skeleton program.cs file. If we want to look at what's inside the C# program file, and it's just a simple main method that prints out hello world. And if we want to run it, we just say .NET run, and it prints out hello world because it runs this main method. So nice and simple, and this way, even if we don't have Visual Studio, it's not too hard to create and manage .NET projects. So coming back, the important thing for us here is not the .NET Core CLI, is the EF Core CLI. EF Core CLI is an extension to the .NET Core CLI. It's not installed by default. So if you never used it before, you'll need to run this command to install the EF Core CLI tools first. I, in fact, haven't used this on this new computer yet. So I'm going to contain multiple lines. Why is containing multiple lines? Anyway, so the first thing you could try is say .NET EF -that version and see if the EF Core CLI is already installed. It's not installed here, and then let's try this one. And this should install it. And if we do this command again, it will say that it installed this EF Core CLI 5.0.7 version. And let's do an update and see if this is already the latest version. Is reinstalled with the latest version. Okay, so it is already the latest version. So once in a while, you may want to try doing an update, because when you update your Visual Studio, I think it doesn't automatically update the EF Core CLI version. So this version may be older than your .NET CLI version. So after a certain time, you may want to do a update if you want the latest version. Anyway, so now we have the EF Core CLI, and this again, it's the documentation. You can find all the commands and what they do and all the options and so on and so forth. So what exactly does EF Core CLI do? Well, it does lots of things, but mainly it does these four things shown as the four arrows in this diagram. First, if we already have model classes, we can use EF Core CLI to generate the so-called migrations. Migrations are basically C# code that creates and or changes tables in a database. And once we have the migrations, we can then use EF Core CLI's tool to either run them to create or change the tables in a database, or we can generate SQL scripts from them. These three things, model classes to migrations, migrations to database, and scripts, these three things are what we'll do the most often. There's also a less common use case where if we already have a bunch of database tables but no model classes, we can use EF Core CLI tool to generate model classes from existing database tables. This is a case usually if your company already has a database used by some other applications, and now they want to use the same database for a .NET Core application, then this would be quite useful. Now, for our purpose, here are the four commands that we'll use the most often. Again, EF Core CLI has a a bunch of other commands and options, but we don't have time to go over all of them. So check out the documentation if you want to use it in some different way. But these four are the four command that we use the most often. So the first one is the one to create the so-called initial migration, meaning that if we have model classes but no migrations and no tables at all, then we want to create an initial migration. And oh, by the way, all these commands needs to be run inside the project folder in order to work. So let me go to the project folder of the EF Core examples, and this is the solution folder, and the project folder is here. So let me copy and paste again. So the command says .NET EF and then migrations and then add. So it's basically saying that we want to add a migration, and the last part is the name for the migration, and this one is arbitrary. You can give it any name. Usually I call it initial schema because I don't have any schema before this. So if we do this, forgot one more thing. In order to use the EF Core CLI tool to generate schemas and so on, we need an additional package called Microsoft Entity Framework for Design. And let's add this dependency first. And okay, so this should do it. Let's save and then go back and then run this again. Okay, by the way, you'll see that it's printing out those two configuration properties again. But that's not important. What's important is notice that it creates a new folder called migrations, and if you look underneath this folder, you'll see some code. Basically, this code creates or changes database table. So if you want to run this code, you don't have to run it directly. You can run it with the EF Core command line tool. So if we want to create the schema inside the database, we can simply do .NET EF database update, and this will update the database schema to the latest migration. We only have one here. Okay, so now if we look at our database, if I refresh here, see that it created two tables. One is the employees table, and one is a table called EF migration history. So this is an automatically generated table, and it contains information about which migration has been applied and so on. Most of the time, you can just ignore that. And this one is the table that's created based on our model class. And if we take a look, we can see that it has ID, first name, last name, date hired, and so on. So just very quickly, we can say John Doe and date hard and something like that. Okay. So now we have one employee in it, and this time if I run this code again, so this should print out John, and if I run this code again, configuration file F settings is not found. That's because this one used to be the copy always file. We rename it to dot sample, and now we need to change this one to copy always, and come on, work this time. Okay, so now it works, and we get the two property values, and we also get the John Doe employee object. Okay, so creating the migration and then use the migration to create database tables. And sometimes we also want to generate SQL script because oftentimes it's easier to look at the SQL script and see what the database schema looks like, and B, sometimes we need to create the same schema on a different database, and having a script is easy to do that. So let's do this one. We already have the migrations, and now why it doesn't let me to Control V? Okay, so this one basically says take the migrations and then generate SQL script and output the generated script to a file called createschema.sql. The file name, of course, is up to you. I usually use the name createschema. And if we do that, let me quickly check. So we want to do migration script. So .NET EF migrations script. And okay, so I think we may need to say initial schema here. Oh, I think maybe because okay, I think I know what's going on. The reason is the dash in PowerPoint is a special character, I think, not the regular dash. So after changing this to the regular dash, it recognized dash O as the option rather than a name. Okay, anyway, if we look at this generated SQL file, we can see that it basically creates two tables, and one is the EF migration history table, again, automatically generated and populated. Don't need to worry about it. And this table is the table that corresponds to the model class here. So this is the command to generate migrations, to generate SQL scripts from migrations so that we can see exactly what the tables look like for our model classes. And the last one is to remove all the migrations and start over. And this is really useful if you want to make lots of changes to your model class, and you can get rid of the old migrations and redo a new migration. So this is pretty much it. Thanks, and see you in the next video.